Alright folks, here we go. Now we get to the fun stuff. This entire lesson is based on solving exponential and logarithmic equations. Now, we have many different types of equations that you could run into, and so this is an extremely long set of notes. There's going to be quite a few videos to go along with them. A lot of them are just going to be me demonstrating sample problems. You can watch them in a faster speed. I'll even speed up some of the work through the video editing as well. In the prior lesson, you learned about the properties of logarithms, and you previously knew about the properties of exponents, and you should also know all of the ways to rewrite from logarithmic to exponent and exponent to logarithmic. All of these different techniques and skills and properties that you've learned are going to become extremely important in your equations that you're going to solve. Now, generally speaking, on the more basic level, so what we've got here are 4 possible types of problems that you're going to see. And so I'm going to say that these are going to be more of the basic variety, not your more difficult problems. So you can see basically an exponential equation where both sides of the equation have an exponent with the same base, or they both have a base that can be created equal. Your second exponential type equation is where you have an exponential on one side but not the other, and so you would need to convert this to a log. Then you have logarithmic equations. Again, you can have a logarithmic equation with the same base on each side, or you can have a logarithmic equation where you only have one log on one side and not the other, and you would need to change it to exponential. Now, we've got a concept box here to kind of give you a thinking strategy of what you should look for first based off what you're given, and then what to do after that. This will be a good resource, good reference for you, but eventually you'll just kind of start to see problems and understand what to do based off what's given to you. So let's take a look at a couple problems here. We're going to start with exponent on each side. So basically we have an exponential equaling to an exponential here. What we want to do is we want to create a situation where they have the same base if they don't already have the same base. And when we do this, we're going to use something called the one-to-one property. So if we look here at example number 1, we have 4 raised to 3x power and 8 raised to the x plus 1. 2 exponential expressions being equal to each other, but they don't have the same base yet. So what we're going to actually do is we're going to rewrite this as a power of a power type property, and so that they would both end up with the exact same base of 2. Now you can see the one-to-one property says if we have an equation where the bases of the exponentials are equal to each other, we can just simply say that the exponential part is equal to each other, and that's where we get 6x equals 3x plus 3. And then we can just simply solve for x there. So go ahead and try sample problem number 1 real quick, and then come back and take a look at the solution. Okay, and you can see here we have x equals to 5 using the one-to-one property. Alright, let's move on to the second example here. In this second example, we now have an exponent equaling to just a number. So we don't have 2 exponential parts here. So this is where we're going to use the skill of rewriting an exponential to a log. Now technically, you can use a property that recognizes that if we raise both sides to the same log value, we can go that route. But you know from a previous lesson that if we want to rewrite this as a log, the log and the exponential are going to have the same base, and we're just going to use this little circular skill to kind of rewrite this. So whether you use it based off of the way example 2 does it, or if you just do a simple rewrite, it's going to come out to be the same either way. Now, when we finally get a log expression, we'll just go ahead and use our calculator to evaluate that. So let's go ahead and work sample problem number 2 and sample problem number 3. And for right now, you can just round to whatever value you would like to. When you're doing Math Excel, please be sure to check the directions in the blue to make sure you know what level of rounding you need. Okay, in sample problem number 3, we have an exponential on the left side, a numerical value on the right side, but we got a little bit more going on with the exponential, so we've got to isolate that first before we can start rewriting it as a log. So we're going to actually subtract 4 from both sides before we do anything. And now we can rewrite this as a log. Now from here, what you're going to want to do more than likely, and if you want to do all this in your calculator at one time, you can, or you can put log 1017 and change it to a numerical value first. Either way works. I'm going to show you the algebraic way here. And so you could have gone all the way through and then just punched this final expression in your calculator at once, or if you'd like, you could have actually changed that to a decimal right off the bat and then just worked with the decimal. And my decimal, your decimal, be a little bit different maybe in the end. All right, we'll stop right there. That's an example of the two exponential types. The next video will work on the logarithmic types. Alright, now we'll take a look at the two logarithmic equation types that you could end up getting. In the first one, we have basically a log on each side of the equation. Now, what we're hoping and what we're going to see initially is each of these logs has the same base. And so if they have the same base, this is another form of the one-to-one property. And what you can see here is that we could basically take this log bases and remove them, eliminate them. That's not technically what's happening, but the final idea here is that you end up with 5x minus 1 equals to x plus 7. And so we can simply solve that algebraic equation very easily once the logs are dropped. So whenever you have two logs on each side of the equation with the same base, that's a pretty easy deal to do. So let's look at sample problem number 4. Okay, and x equals to -2. Now, one of the things I haven't mentioned up to this point that was put in the notes very early on, and I didn't touch on it as much as I should, is that anytime you're solving exponential or logarithmic equations, you always need to check for extraneous solutions. And at this point, we haven't really had any, and we haven't really checked for it as we need to, but it's something that you need to get in the habit of doing by checking in your calculator and making sure that you're dealing with valid solutions. Alright, let's take a look at the next example. In the next example, we're at a situation where we have a log on one side equal to a number on the other side. And so this is going to go back to rewriting logs to exponents. And if you recall, just again, this little circular technique that we've used in the past to help us rewrite things. And then once you get it in exponential form, again, it's a simple algebraic equation for you to solve. And so we'll take a look at sample problem number 5. Okay, and that's simply how you would solve with one log on one side of the equation. Let's go ahead and finish one more problem here. Sample problem number 6. We have a scenario here where you have two logs on the left-hand side of the equation. What we want to do now is you want to think of how can I use my log properties to condense this on one side of the equation so that I can solve it the way we just solved the prior problem. So go ahead and work problem number 6 real quick. Alright, and you can see here that we use the log property from addition to multiplication. We combined those two logs into one singular log and we multiplied their parts, and then we were able to convert it to an exponential equation from there and finish solving. Alright, so that's a good example of the different types of log equations that you may run into. In the next video, there are quite a few sample problems remaining in the notes. Be a good idea to just try to go ahead and work those. Each one of them has different complexities and little nuances that are different that you're going to have to adjust to. And be sure to check for extraneous solutions and then come back in and watch the solutions in the next video.